Very good afternoon to all and welcome to my class. This is your first class for this session, right? So, I welcome you all in your 12th class. What we are going to do today now, we are going to do some basic things that really required in chemistry, and their importance is very much, very much is needed for the calculation of various concepts. So today we are basically going to study type of mole concept and what are the various small tips and tricks that really use in your coming 12th classes, right? So I welcome all of you. Please join us and let's start with the today session, right? Everyone, yeah. So okay. Basically, as I already told now, today we are going to discuss the mole concept and the equivalent concept, because these small things are really important for you all. And by using this concept, actually you got to know that how things are really happening in chemistry, right? So these are the basic things you need all time. Whenever you're doing some numerical, some concept, these type of things you always require, right? Uh, let's start with the today session. Okay, my voice is clear to everyone. Is I'm audible to everyone, right? Okay, okay, okay. So if you have any doubt related with any queries, anything which you want to know, please text me in the chat box. I'm replying each and every queries of you, right? So let's start with the today session. That's what we are going to study today, right? Okay, so first of all, now this seems to be very simple, as we all know that what is molecular masses and how will you calculate this, what is the molar masses. But these things are really important for you, because in every numerical related to physical chemistry, na, you need how to calculate molecular mass. You must know how to find the molecular mass of a molecule, of an element, or anything, right? So for these small things are very important. So what is molecular mass? As you already know, because you study these all things in your 11th class, right? So what is molecular mass, beta? What is molecular mass? That is, it is the sum of the atomic masses of the element present in the molecule. If I'm talking about any molecule now, so it is the sum of the atomic masses of element that is present in a molecule, and it is normally calculated for the covalent compound as they have a definite molecular structure, right? So if I'm talking about molecular mass, so this point is very much important, right? It is the sum of the atomic masses of element present in the molecule, and it is normally calculated for covalent compound. Okay, so whenever you talk about the molecular mass now, always remember this thing, that this molecular mass is calculated only for the covalent compound. For ionic compound, we have a different mass, like a formula mass. We are going to discuss this thing as well, right? Now, so what is molecular mass, beta? So it is the sum of, then just adding, it is the sum of the atomic masses of element present in the molecule, and it is normally calculated for the covalent compound as they have a definite molecular structure. I hope this is clear to everyone. Yes, beta. Is it clear to everyone what is molecular mass? No doubt related to this topic? No, right. Now, how will you obtain this, beta? So it is obtained by multiplying the atomic masses of each element by the number of atoms, right? It is obtained by multiplying the atomic masses of each element by the number of its atom and adding them together, right? For example, if I'm talking about the molecular mass of glucose, then how will you calculate, beta, the molecular mass of glucose? We all know glucose having formula C6H12O6, right? Now we have to calculate the molecular mass of glucose. Then how we'll calculate, beta? In this glucose molecule, we know that there's a 6 carbon atom, there's a 12 hydrogen atom, and there's a 6 oxygen atom as well. So we can multiply, na? That is 6 into 12. Yes, yes. Any doubt, beta? Okay. Anyone having any doubt? You can ask, beta. No issue. No? Right. So, for example, we have to calculate the molecular mass of glucose. Then what is the molecular mass of glucose, right? This is C6H12 and O6. So we can calculate as 6 into multiply atomic mass of each element. That is atomic mass of carbon is what? That is 12 into, for example, for hydrogen. How can you calculate the molecular mass of hydrogen, beta? Just multiplying 12 with the atomic masses of hydrogen and just for the oxygen. So we can calculate the molecular mass of glucose like this, and this comes out to be 180. So this is how we can calculate the molecular masses, right? I hope is it clear to everyone? क्लियर है सब, ये कोई इशू नहीं है? Okay, now let's move to the next thing, that is the for ionic compound. What we can do, we know for the covalent compound we calculate molecular masses, right? Now for what we do for the ionic compound, so similar, just like a molecular mass na beta, we also calculate formula mass, right? So how we'll calculate formula mass, beta? How will calculate formula mass? The formula mass of the substance is actually the sum of the atomic masses of all atoms in the formula unit of the compound. Just remember this thing. It is the formula mass of the substance means what? It is the sum of the atomic masses of all the atom in the formula unit of the compound. In case of molecular masses, it is sum of the all the atom present in a molecule, and here all the atom in the formula unit. Just remember this concept, right? The second and most important point is it is normally calculated for ionic compound as they don't have any definite molecule, right? If for example, if I'm talking about NaCl, so what is the formula mass of NaCl, beta? That is 23 plus 35.5. It comes out to be 58.5 AMU. AMU is what is AMU here? That is atomic mass unit, and it is also represented as U, right? So this is how we calculate the formula mass. Similar, if for example, if you want to calculate the formula mass of, that is calcium chloride, we can also calculate. We know calcium having atomic mass what, beta? That is 40, and chloride having 2 into 35.2. This comes out to be 40 plus 70. So 40 plus 70, that is 110. 110 U. So this is the formula mass of calcium chloride. So by doing this, we can calculate formula mass and molecular mass. So these things are, I know you already know this thing, but this thing is very important for your, upcoming chapters that we are going to start in our 12th class, right? So these things you must remember while solving such numericals. Now, this one is very important concept, right? So please give your attention to this concept because this concept is really asked in your every time. For example, if I'm talking about the electrochemistry or redox reaction, these types of things are really required to solve question. That is, what is the role of equivalent mass or equivalent weight, right? So let's see what is equivalent mass or equivalent weight actually is this, right? So beside the molecular and the formula mass, right? Beside the molecular and formula mass, the masses of compound are also calculated on the comparative basis, right? For covalent compound, we know we can find molecular mass. Similar for the ionic compound, we can calculate formula mass. But the masses of compound are also calculated on this comparative basis. What is mean by this term comparative basis, beta? Comparative basis means in relative to the another. For example, if I'm saying mass of the sodium is 11 times more heavier than hydrogen, right? Mass of the magnesium is 12 times heavier than that of hydrogen. So this is known as relative terms, right? This is known as relative, that is comparative to some. By fixing one fixed, and by using this we can calculate others mass, right? So how the concept of equivalent mass really comes into the picture now? Just look at the point number 2, that is the number of parts of substance. Remember this, the number of parts of substance that combine with or displace, maybe directly or indirectly, 1.008. What is 1.008 AMU? What is whose mass is this, beta? 1.008. This is the atomic mass of hydrogen, right? The number of parts of a substance that combine with or displace directly or indirectly 1.008 part by mass of hydrogen or 35.5 mass of chlorine, or we say 8 parts by mass of oxygen, is called equivalent mass of their substance. Samjhe? It means what it means. That is, equivalent mass is nothing but it is the mass which can replace directly or indirectly 1.008 mass of hydrogen, or we say 35.5 parts of mass of chlorine, or we say 8 parts of oxygen. So these three things, that is hydrogen, chlorine, and oxygen. These three things, on the comparative basis of these three things, we can calculate equivalent mass. For example, mathematically, how we'll write as that is the equivalent weight of the substance A. That is, we have to calculate, okay, upon equivalent weight of the substance B is equal to weight of the substance A upon weight of the substance B. Now, one more important here. If A is a metal, let us consider if A is a metal and B is anything, either it will be hydrogen, oxygen, or chlorine, right? Then how will calculate equivalent weight of the metal? Because I assume here A is a metal. Okay, so if A is a metal and B is out of these three anything, that is hydrogen, chlorine, and oxygen. So how will you calculate the equivalent weight of the metal? The nothing but equivalent weight of the metal is equal to mass of the metal divided by mass of the hydrogen displaced multiply by 1.008, or we can also calculate like mass of the metal upon mass of the oxygen combined into 80, or we can also write as mass of the metal upon mass of the chlorine combined into 35.5. So by using these three methods now, we can easily calculate equivalent weight of a metal. Okay, so for any time if someone asks how will you calculate the equivalent weight of the iron, how will you calculate the equivalent weight of the metal like chromium, like manganese, how will you calculate this? So we can calculate the equivalent weight of the metal by using this concept, right? That is the mass of the metal divided by the mass of the hydrogen displaced multiplied by 1.008. I hope is it clear to everyone. Anyone having any doubt, please ask me बेटा. किसी को कोई भी डाउट है क्या अभी तक? No? Shall I proceed? Yeah. Shall I proceed? Okay. Right. Okay. So this is how you can calculate the equivalent weight. Now, similar, if you want to calculate the equivalent weight of an acid, then what you can do? Just remember this simple trick and simple formula. You can easily calculate the equivalent weight of an any acid, right? Equivalent weight of an acid is nothing but it is equal to molecular weight of acid divided by this term basicity. What is this term basicity here, beta? What do you mean by this term basicity? You are surprised to know that we are talking about the equivalent weight of acid. Now, where, sir, basicity comes? So what is basicity actually means now? Basicity means that is the number of replaceable hydrogen, right? Number of replaceable H plus. That is defined as a basicity. I'll draw the diagram as well, then you'll get a better idea of this, right? So what is the equivalent weight of acid? For example, if I'm calculating the equivalent weight of H2SO4, so we know that the molecular weight of H2SO4 is nothing but 98. How will you calculate beta? H2SO4 having molecular weight 98. How will you calculate this? Yeah. How will you calculate? We know that hydrogen having 1, sulfur having 1 into 32, and we have a 4 oxygen atom. So 4 into 16, right? So this comes out to be 2 plus 32 and plus 64. This comes out to be beta 98, right? So this is 98. So this is the molecular mass of what? This is molecular mass of nothing but H2SO4, right? So this is the H2SO4. Now basicity here is 2. Now, because it in H2SO4, there is a 2 replaceable H are present. So you are excited to know now. How can we know there is a 2 H plus present or 3 present, or there is more than 2 or 3, or even there is no H replaceable is present. So how will you get to know beta? So just by drawing the structure of H2SO4, we know that in our 11th class in chemical bonding, we used to draw the Lewis dot structure for the molecule, right? So just like that, if I draw the structure of H2SO4, so what is the structure of H2SO4, beta? It will consist of, right? This is SOO and this is OH and this is OH, right? So it having two replaceable, H plus. So it basicity is two. That is two OH group is there, right? There is a two OH group. If OH group is three, then basicity become three. If the OH, for example, if I draw the shape of H2 H2O7. Now, in this case, if someone asks, how will you say whether it will contain, two replaceable H plus or one replaceable H plus? How will you know it? If you know the structure of this, right? That is S double bond O, S double bond O. Again, that is SO, SO, right? So how many O are left with us still? Still we have a 1, 2, 3, 4. That is 3 O are left. And how many H? That is 2. So this is OH, 1 OH, that is 1 OH and 1 O is here. So in this also, what is the basicity of this beta? Only 2, right? So basicity comes out to be 2 here as well, right? So I hope it is clear that how will you calculate the basicity, right? So whenever you have to calculate the equivalent weight of an acid, just calculate molecular weight of the acid divided by the basicity. I hope it's clear to everyone, right? Clear? Any doubt, beta? You can text me. Any doubt related to this one? No? Shall I proceed? Right. So this is how you can calculate the equivalent weight of an acid. Similar way, if someone says just calculate equivalent weight of base as well. Now, how you can calculate the equivalent weight of base? Just like equivalent weight of an acid, by using the same concept, we can also calculate the equivalent weight of base. For example, if you want to calculate the equivalent weight of base, just divide molecular mass with the acidity. That is here the number of replaceable OH negative ion, right? For example, if we considering NaOH, then NaOH having how many replaceable OH beta? Only one. So that is 40 upon 1. Now, if someone says that calculate the equivalent weight of MgOH2, MgOH and 2. So how will you calculate how many of replaceable OH are present here beta? 2. And what is the molecular mass of MgOH? Can you calculate? We know that magnesium having molecular mass 24 and there is a 2 oxygen to 2 into 16, right? Plus 2 hydrogen. So that is 2 into 1. So it comes out to be beta 24. That is 24. This is 32 and this is 2. So just do the sum of this. 24, 32 and 2. This comes out to be 4 to 6 to 8, right? And this is okay. So this will comes out to be, right? That is 24. This is 24 now and 32 plus 2. So this comes out to be 4 to 6 to 8, right? And 3 to 5. That is 58. Okay. So just divide 58 by what? Just divide 58 by how many replaceable OH are present here in MgOH2? In NaOH2, NaOH, only one OH is replaceable. So in MgOH2, how many OH are replaceable, beta? That is 2. So you can just divide this, right? So by using this concept, you can also calculate the equivalent weight of base. So I hope is it very much clear that how we do calculate equivalent weight of acid and equivalent weight of base. Clear है सबको यहाँ तक? No issue? Right. Now, next move to the next one. That is how will you calculate the equivalent weight of a salt? Right. If I'm talking about, NaCl, copper sulfate, Na2CO3, then how will you calculate the equivalent weight of salt? Nothing but it having also a very much similar formula like molecular weight of the salt. So you observe very carefully that in whether we have to calculate equivalent weight of an acid or base or salt, always divide with the molecular weight, right? That is the molecular weight of acid, molecular weight of base, here molecular weight of the salt, divided by the total positive valency of the metal atom, right? If I'm talking about Na2CO3, so we know that molecular mass of Na2CO3 comes out to 106 and divided by what beta? That is the positive valency of the metal. So Na having +2, right? And because we know that Na having +1 oxidation state. So here the two Na are there, na? So it become +2, right? So this is total number of plus charge having +2. So this is how you can calculate the equivalent weight of salt, right? Similar, if I'm talking about then how will you calculate the equivalent for like copper sulfate? If we have a copper sulfate, then how will you calculate the equivalent weight of copper sulfate, beta? This is also salt, na? So how will you calculate? Can anyone tell me how will you calculate the equivalent weight of copper sulfate? Anyone? Yes, beta. Anyone can tell me how will you calculate equivalent weight of copper sulfate? Right? Yeah. How will you calculate, beta? Just divide its molecular mass with the total positive valency of the metal, right? If I'm talking about copper sulfate having molecular mass, beta, we whenever such type of a salt are given where the element lying having atomic number greater than 30 or 40 or more than 20 even also, so their atomic masses are already provided, right? So there's no worried in that case, their molecular masses is provided. So we are given that copper sulfate having molecular mass 63.5, right? And for sulfur, that is 32, and for oxygen that is 4 into 64. Just calculate this beta. So it comes out to be how much? That is just calculate. That is 63.5, 63.5 plus 32 and plus that is here small mistake 16 into 4, that is 64, right? 64. It comes out to be 159.5. 159.5. So this is the molecular mass. Now what is equivalent weight of this beta? Equivalent weight of copper sulfate, that is 159.5 divided by ये तो चलो अब ये तो बता दो सभी, from what factor we divide this term? 159.5 divided by what? 1 2 3 divided by what is the what is the valency of the copper here? Copper having oxidation state here, can anyone? Beta, you just here you have just calculate total positive valency of the metal atom. So we know that in copper sulfate, copper having +2 and sulfate having -2. We all know that this thing. So just divide by 2. So we can calculate here equivalent weight of salt, right? So this is how you can calculate equivalent weight of the salt, right? So we already see how to calculate equivalent weight of acid, how to calculate equivalent weight of base, and how to calculate the equivalent weight of salt. Now, the next is how will you calculate the equivalent weight of a substance that undergo oxidation or reduction, right? This one is very important, right? This is one is very, very important for any substance which undergo oxidation and reduction. How will you calculate their equivalent weight, right? So let's see how will you calculate the equivalent weight under the substance undergo oxidation and reduction. For this also, just divide this molecular weight, for example, molecular weight divided by change in the oxidation number, right? Let's see with this some example, right? Then you can understood this in a good way. Now, when the KMnO4 reacts under acidic condition, change in the oxidation number observed from 7 to +2 is 5, right? For example, here KMnO4 is present, right? KMnO4, and this is in acidic medium, and if they will give Mn +2, just remember this. So we know that here the oxidation number of Mn is what? Can anyone calculate the oxidation number of Mn here? Anyone? We know that K belongs to the first group, so having valency 1. And we have to calculate for X. We know that oxygen having valency -2. So -2 into 4 comes out to be -8 is equal to 0. So X comes out to be beta. That is 8 minus 1. That is 7. Right? That is 7. So here the Mn having +7 oxidation state, and here Mn having +2 oxidation state, right? Okay. Now, when the KMnO4 react under the acidic condition, change in the oxidation number is from 7 to 2, with that is 5. So what is the change in the oxidation number, beta? That is, it will become 7 to 2. So total change is 5, right? Total change is 5. Hence, the equivalent weight of KMnO4 in the acidic medium is 158 divided by 5. That is 31.6. So this is how you can calculate the equivalent weight of substance that undergo oxidation and reduction. I hope is it clear to everyone, right? That is how will you calculate the equivalent weight of the substance that undergo oxidation and reduction. Okay. Now, for the volatile metal chloride, equivalent weight and the atomic weight are related as this. That is, the atomic weight is equal to equivalent weight multiplied by valency, nothing else. Right? So this is the very important thing, and that we are understand, that is how will you calculate the equivalent, right? For equivalent weight of an acid, equivalent weight of a base, equivalent weight of a salt, and last but not the least, that is the equivalent weight of the substance that undergo oxidation and reduction, right? So this is how you can calculate the equivalent weight. I hope is it clear to everyone. Anyone having any kind of doubt, beta, related to this topic now, you can ask, beta. Yes, beta, you can ask. Anyone having any doubt, then only I'm going to the next topic. Any doubt, you can text me or you can ask me. No issue. I hope you understand. Yeah. Okay. Okay. So let's move to the next topic, that is after this some remember points here are some notable points here which you must be remember, right? What these points are: first, that is the atomic, right? That is the atomic and molecular masses of element, right? Atomic and molecular masses of element and compounds respectively are always constant, right? Just this point is very much important, and this type of question come in assertion reasoning type of question as well. So these points are very very important, just take care of them, right? So what the first point state, that the atomic and the molecular masses of element and compound respectively are always constant, but equivalent masses may vary with the change of valency. Yes, it will be happen. For example, in some, their oxidation takes place from +2 to +4. So here the change in oxidation state is 2. If somewhere their oxidation changes takes from 2 to 7, then total changes there is 5. So their equivalent weight is changed by time to time, right? So this is important thing, that is the atomic and the molecular mass of the element are always constant, but the equivalent mass may be vary with the change of the valency. Yeah, good. Now, the next one is the valency of the element forming isomorphous compound, that is the compound that have the similar constituent. What is that, beta? Isomorphous. What is this mean by this term isomorphous? Isomorphous means that is the compound that have the similar constituents and chemical formula are same. For example, the valency of chromium, selenium, and sulfur are same, right? If I'm talking about K2Cr2O4, Cr having valency, this one having beta 2, oxygen having 8, so this having valency +6. Here selenium K2O, again this comes out to be +6, and this is also +6. So in all these three, they having same valencies, right? So these type of compound are known as isomorphous. Isomorphous means the compound that have a similar constituents and chemical formula are same. That is their valency are same, right? Now, so this is all about the mole concept. Sorry, this is all about the equivalent concept, right? So we learned a lot of thing in this equivalent concept, and just try to remember this thing as well, because in our coming chapter, there is an electrochemistry solution. We are going to use this term. We are going to calculate equivalent weight. For example, if normality, someone asks, how will you find the normality of the solution? Then in normality also, we use the same concept of equivalent, right? So just learn these things, right? Just remember this thing. Okay. Now, next move to the one most important condition after the equivalent condition is, that is a mole concept. And this thing you are studied from your ninth class, from your ninth class, you have studied this all thing. That is 1 mole is equal to this much of atom. 1 mole is equal to this. So this kind of thing, you know already, right? So here, what I'm going to do now, I relate this mole concept with your calculation, that how you can calculate physical chemistry questions. How will you use this concept in a right way so that you can able to interrelate, concentration, moles, equivalent, all these things together. And by doing this, you can able to solve question related to this topic, right? So what is the mole concept? Basically, the mole, the word mole was introduced around 1896 by the W. Oswald, who derived it from the Latin words. What the moles means? Moles means a hip or a pile. It is represented by the symbol MOL. Just like, we use certain things. For example, we say now, you all, this thing, that 1 dozen is equal to how 12 quantities. So whenever some quantities are 12, we can say it is 1 dozen, right? So 1 dozen means that is any quantity having how much having this quantity, beta, actually 12 quantity, right? So for 12 we use 1 dozen, right? Similar, we can say that for the 6.023, just remember this word, that is 6.023 into 10 ki power 23 atoms. This much of entities combined together to form 1 mole. Okay, it means what is 1 mole, beta? 6.023 into 10 ki power 23. This much of atom, molecules, iron, this all term as 1 mole. It means if someone say 1 mole of hydrogen react with 1 mole of oxygen to form water. If someone say, so 1 mole means this much of atom, that is 6.010 raised to the power 23 atoms of hydrogen react with this much of atoms of oxygen to form this much atom of water, right? So this is a whole idea, about the concept of this thing. That is 1 mole. So 1 mole of the substance always mean this entity of that substance. It is also called Avogadro number, or we say Avogadro constant, and represented by Na. So how will you represent with a mole concept? That is a 1 mole, that is a Na, that is a Avogadro number, right? So technically, how will you define 1 mole? So technically, we can define 1 mole, that is the amount which weight exactly same as if the formula weight in gram, atomic mass in gram, or molecular formula mass in gram, right? So it is the amount which exactly same as that the formula weight in gram, for we formula we use for the ionic compound, right? Atomic mass in gram or molecular formula mass in gram, right? The amount which has the same number of entities, that is the it may be atom, molecules, or other particle, as there are atom in exactly 0.01 kilogram or 12 gram of carbon C12 isotope. This number is equal to Avogadro number. It means 12 gram of carbon, right? 12 gram of carbon, the weight of the 12 gram of carbon contain 6.023 into 10 ki power 23 atoms, right? Exactly the molecules or the ion or other particle may be, then there are atom in exactly this much of gram. But it means, for example, if I'm talking about hydrogen, so hydrogen having only 1 gram. So in 1 gram, they having this much of atom, right? That is 1 mole. So 1 mole of hydrogen means 1 mole of hydrogen means that is they contain 1 gram. 1 gram contain 1 gram of hydrogen contain 6.02 into 10 ki power 23 atoms, molecules, or ion. Similar, if I'm talking about sodium, so we know that sodium having molecular mass beta what? That is 11 and 23. So it having molecular mass of 23. So 23 gram of sodium is equal to Avogadro number. That is Na. right? So this is you calculate, this is equal to Na. Similar for magnesium. So just remember this one simple thing, that is 1 mole is always equal to, right? Later I'm going to discuss as well. So just wait for a minute, then we'll discuss this thing as well. Now, the amount which occupy 22.4 liter at STP, if it's taken for a gas, that is also known as 1 mole, right? Now, this thing you must remember, because thus the formula, these are the formula basically used for the convert amount of substance into moles and moles into the amount of substance. Just remember one thing better. What? That is 1 mole is equal to 6.023 into 10 raised to the power 23 atoms, or it may be molecules, right? It may be molecules. Okay. And 1 mole is always also equal to 1 mole equal to Avogadro number. This one is, and 1 mole also equal to the molecular mass. 1 mole is also equal to the molecular mass, right? So by this two equation, we got to know that is molecular mass is nothing but the mass of the 6.023 into 10 to power 23 atoms is known as molecular mass, right? Okay, so how will you calculate the mass and the moles related to each other? How is this formula really useful for calculating the whether we have to calculate the number of moles or we have to calculate the weight in gram and so on. So the first one is the number of moles of the molecule is equal to weight in gram divided by the molecular or the formula weight, right? For example, if we want to calculate the number of moles of carbon, right? So in 12 gram, so just divide 12 gram of carbon and divided by the molecular mass of carbon is also 12. So this comes out to be 1 mole. So this is 1 mole, right? Similar, number of moles of atom is equal to weight in a gram divided by the atomic weight. Similar, number of moles of particle is equal to number of particle divided by the Avogadro number. This one is very important. This one is very, very important. That is, number of moles of the particle is equal to number of particle divided by Avogadro's number, right? And the next one is that is the number of mole of gases. So how will you calculate the number of mole of gases, beta? That is the volume of gas at STP, that is in liter divided by 22.4. So just remember this, four formulas. This four formulas very, very important, that how will you calculate amount of the substance using mole, right? So these four formulas are very important. Anyone having any kind of doubt beta related to this mole topic? Any doubt related to this mole concept? You can ask. Is it clear? How will you calculate the weight of the substance using mole? Right? Okay. Let's see some example. For example, 1 mole of NaCl, we all know that is a 1 mole of NaCl contain 6.023 into 10 to the power 23 NaCl units. Or we say 6.023 into 10 to the power 23 Na units of Na plus, similar units of Cl negative, right? That is the mass of 1 mole of NaCl is what? That is 58.5 gram of NaCl. Thus, we can say that 58.5 gram of NaCl contain this unit. Okay, so while solving problem related to mole concept, always keep in mind the following some important points, right? This point must be kept in your mind. The first, convert all in the same unit, whether it will be mole, atoms, masses, right? And then compare. And one important thing, moles is directly proportional to the molecule. If the someone having the more number of moles, it implies that having the more number of molecules. So moles is directly proportional to molecule as well, right? Now, one important and concept based question here, that is you have to calculate the number of atom present in 1 mole of element and it is equal to Avogadro number. So which of the following element contain the greatest number of atoms? So out of this four option, you have to calculate, which of the following contain the greatest number of atoms. So just use a simple trick here. Nothing. We know that 1 mole is equal to what? Just say 1 mole is equal to what, beta? Avogadro number, Avogadro number. And 1 mole is also equal to molar mass, molar mass. Right, 1 mole is also equal to molar mass. Now, just use this simple formulas and you can get to know which of the following out of these four contain maximum number or greatest number of atoms. For example, if I'm talking about 4 gram of helium, so we know that 1 mole of helium, 1 mole of helium, right, 1 mole of helium contain how many number beta Avogadro number, that is Na, that is Na, right? This is Na. Let me write again. This is Na. And now 1 mole of helium also equal to molecular mass, that is 4. So 4 gram contain, 4 gram contain how much of atom? That is 6.023, 10 ki power 23 atoms, right? So 1 gram of helium contain, 4 gram contain this much of atom only, right? Okay. On the similar basis, you can calculate for sodium also, right? We know that molecular mass of sodium is 23 gram. So 23 gram contain Na atoms. So 46 gram contain beta 2 into Na atoms, right? So just twice, 2 into Na. Similar, we know that for calcium, calcium having molecular mass 20. So 20 contain Na. So 0.4 contain beta. For example, for 1, we have calculate Na divided by 20 into 0.4. So we can calculate this. And similar for the 12 gram of helium. So we know that 4 gram of helium contain this. So 1 gram of helium contain how much? 6.023 upon 4 into 12. That is 4 into 3. So 3 times of Na. Right? 3 times of Na. So out of these four, which will contain maximum number of atom beta? Let's see the solution. That is, this will contain only 1 mole, this will contain 2 mole, 0.1 mole, and this is called 3 mole. So we know that therefore the number of atom are highest in 12 gram of helium because they contain 3 mole, 3 into Na, 3 into Avogadro number, right? So out of the four options, 12 gram of helium contain more number of atoms, right? So I hope is it very, very simple question. And this type of questions really ask in a conversion where you have to calculate the relation between the moles and the number of atoms, right? So this is all about. So I hope this is clear to everyone, right? Okay, so this is all about the today class. That in this class we studied about the mole concept and equivalent concept. So I hope is it clear to everyone? Yes, beta. सबको clear हुआ सब कुछ यहाँ तक? Any doubt related to this topic? Or is it clear to everyone? Just give me a thumbs up or text so that I know that it is clear to everyone. Right? Okay. Okay. So let's end the today's session, right? And the next class we are going to discuss one more important thing, that is the chemical bonding. And in this chapter we are going to study about the shape, hybridization, and all these things. So just before this, just learn this topic and try to understand and memorize this concept as well. That is how to calculate equivalent weight and the mole concept. Okay, let's meet in the next class. Till take care.